A planet of mass m is in a circular orbit around a star. The gravitational potential due to the star at that position is V. Show that the total energy of the planet is given by the equation shown. Total energy. All right, so what you're going to do here is you're going to do this, right? That the total energy is equal to 1/2 mv squared, right, plus negative, and then what we can do is just say the potential times the mass of the planet, right? When we solved these, we said minus gm over r times the mass of the object, right? But this thing right here, this is just the potential, right? Okay. And then, of course, what we can do is substitute. We can substitute. Oh, look at that. We can substitute the total energy of the planet. Interesting. It should be. Oh, I see. Because that's going to be a negative number. Okay. And then what we can do is substitute the square root of gm over r into that, right? Okay, when you do that, you're going to end up with a positive, basically mgm over r, right? And then you're going to, and then you'll end up with negative this, right? And then therefore it's going to end up being this, okay? So just make a substitution, simplify this expression, right? Keeping in mind that gm over r, and that's a big M there, right? That is our potential, right? Remember that substitution, then you're set, right? Suppose the star could contract to half its original radius without any loss of mass. So they're saying, like, here's the star and here's this planet, right? This is before, and then after we contract that star down to something like this, right? But it's the same mass, right? Which never happens, but because usually these collapses involve a catastrophic, explosion that sends material into space. But let's just imagine hypothetically that we could do that, right? Remember that the formulas don't depend on the radius of this planet. They depend on this center-to-center distance, right? So it's not going to change the orbital speed. It's not going to change the force of gravity. It's not going to change the gravitational field out here, right? And it's certainly not going to change the total energy of the planet, okay? Good luck.